Hello student, welcome in our 13th lecture. In the previous lecture we have started our third chapter, that is gas chromatography. In that chapter we discussed the components of the gas chromatography. Out of 4 components we already discussed 2 components, that is carrier gas and sample injection. So these 2 components we have already discussed. Now in the today's lecture we will discuss the remaining 2 components, that is columns and detectors, which are used in gas chromatography. So the content of the today's lecture is column used in gas chromatography and the detectors used in gas chromatography. So first we proceed through the columns. There are 2 general types of column. The first one is packed column and the second one is capillary column. So these packed columns are finely divided inert solid support material coated with the liquid stationary phase. And most packed columns are having length 1.5 to 10 meter and have the internal diameter 2 to 4 mm. While the capillary columns have internal diameter is usually 0.1 to 0.5 mm and the length ranges from 10 to 100 meters. So it is very large one. Okay. These are mainly of 2 types. This capillary column is having 2 types, that is wall coated open tubular capillary column. In short we call it as WCOT. And second one is support coated open tubular capillary column, SCOT. Out of these 2 columns, capillary column having length is bigger one, 10 to 100 meter, while the packed column has only 1.5 to 10 meter. Okay. So we see the types of this capillary column. Wall coated columns consist of a capillary tube whose walls are coated with a liquid stationary phase. So see here, wall coated open tubular column. This inner wall, it is coated with the liquid stationary phase, while in the support coated column the inner wall of this capillary, it is lined with the thin layer support material onto which the stationary phase has been adsorbed. This is a thin layer support material on which the stationary phase has been adsorbed. Okay. While these SCOT columns are generally less efficient than this wall coated open tubular column. Both types of capillary columns are more efficient than the packed column. This is a packed column. These two are more efficient. So large amount of sample is introduced here. So it is a more efficient than the packed column. Okay. Then we see the difference between packed column and capillary column. So here the figure is there. So we observing that figure, we can discuss this difference. Typically a glass or the stainless steel coil is used here. 1 to 5 total length and 5 mm in diameter. It filled with the stationary phase or packing coated with the stationary phase. So here the stationary phase is packed. Okay. While in the capillary column, it is a thin fused silica, typically 10 to 100 meter in length and 250 micrometer in inner diameter. The stationary phase is coated on the inner surface. This is the stationary phase coated on the inner surface, provide much higher separation but more easily overload by too much sample. Here too much sample is overloaded. Okay. So this is the difference between packed and capillary column. Then so with this we complete the gas component, that is column. Okay, next is the detector. First, what are detectors? A chromatographic detector, it is a device used in gas chromatography or liquid chromatography to detect the components of the mixture being eluted off the chromatographic column. That means the elution of sample is done by the column, that is detected by the detector. So these are some characteristics of the good detectors. They are reproducible response to the change in elute composition. It should be response rapidly, high sensitivity, low noise, small volume to avoid the peak broadening and resultant loss of resolution, preferably non-destructive. Okay, these are some good characteristics of the detectors. Then we see the detectors which are used in GC. Detection devices for the GC must respond rapidly and reproducibility to the low concentration of the solutes emitted from the column. This detector, it is divided into two categories: concentration dependent detectors and mass flow dependent detectors. So concentration dependent detectors involve these detectors: thermal conductivity detector, electron capture detector, argon ionization detector, helium ionization detector. While in the mass flow dependent detector, the flame ionization detector, nitrogen phosphorus detector, flame photometric detector. Okay, so in the GC there are different types of detectors are used. So out of that detectors, we are going to discuss only the three detectors, that is FID, TCD and ECD. Means thermal conductivity, electron capture and flame ionization detectors we are going to discuss in the today's lecture. Okay, so we start with the first, that is flame ionization detector. This detector, it is a mass sensitive detector. It is mass sensitive detector and it was invented by the scientist Hurley and Pretorius and separately by McWilliams and Dewar. So these scientists invented this FID. Okay, the flame ionization detector for the GC, it is operated by the principle that change in conductivity of the flame as the temperature is burned. Flame ionization detector for the GC, it is operated by the principle that the change in conductivity of the flame as the compound is burned. So here the figure is given. In this figure, the hydrogen gas is introduced. In presence of air or the oxygen, this get burned and it create a flame. Okay, means it make a use of an oven. Means here the temperature is increases, so it is a similar to the oven temperature. It heat the sample wherein a flame is produced by burning the hydrogen gas in presence of oxygen and air. Effluent from the column is directed into the air and hydrogen flame. They directly come in contact with this flame. A definite potential difference is maintained between the two electrodes with the help of series of batteries. Amplifier and recorder record the chromatograms. Okay, so this is about the flame ionization detector. So you have to remember only that it is a mass sensitive detector, and in this detector the hydrogen gas, it is burned in presence of air and oxygen. It produce flame and that flame heat the sample, heat the effluent from the column, and finally we record the chromatogram. Okay, so you have to remember this part. Then the next is thermal conductivity detector. In short, we called it as TCD. TCD was one of the old detectors for the GC. It's still widely in use. It is also known as a cathometer and hot wire detector. What it known? Cathometer and hot wire detector. Then the principle of this TCD is based upon the changes in thermal conductivity of gas stream brought about by the presence of analyte molecules. Means it is totally depend on the thermal conductivity of gas stream brought about by the presence of analyte molecule. The sensing element of this TCD is an electrically heated element whose temperature at constant electrical power depend upon the thermal conductivity of the surrounding gas. The heated element may be a fine platinum or gold or tungsten wire or semiconducting thermistor. Okay, the thermal conductivity of most of the sample is lesser than most commonly used carrier gas like hydrogen and helium. So you have to remember it is a very old detector, most commonly used. It is known as cathometer and hot wire detector. Then you have to remember the principle. Then the last detector, that is electron capture detector. In short, we called it as ECD. This ECD was invented in the year 1954. It consists of a beta emitter such as nickel adsorbed on the platinum or the titanium foil. While in this electrode, the two electrodes are on either side. Two electrodes are on either side of the emitter and they are connected to the ammeter for the record the current in the circuit. What I am saying here, this ECD it uses a radioactive beta emitter, that is the electrons, to ionize some of the carrier gas and produces a current between a base pair of the electron. When organic molecules that contain the electronegative functional group such as halogen, phosphorus and nitrogen group pass by the detector, they capture some of the electron and reduce the current measured between the electrodes. The ECD is as sensitive as the FID but has a limited dynamic range and find its greatest application in analysis of halogenated compounds. That means you have to remember only this ECD detector. It is the most commonly used for those compounds which are containing the functional group like halogen, phosphorus and nitrogen. Such organic compounds are detected by using this detector. Then in this detector a radioactive beta emitter, that is N63. This radioactive beta emitters are used. Electrodes are used. The electrodes produce a current and that it is recorded in the circuit. Okay, so you have to remember this part only. With this we complete the columns and detectors which are used in gas chromatography. In the next lecture we discuss the stationary phases used in gas chromatography. Okay, you have to write down the notes during the lecture.